Today, we are going to find capacitance of a parallel plate capacitor when conducting slab is placed in between the plates. Now, if you remember when we did parallel plate capacitor, we derived the formula of capacitance that was epsilon naught A by D. A was the area of plate and D was the distance between the two plates. In this case, what we have done in last case, there was nothing in between, there was no medium here, but now we have placed a conducting slab, right? This orange color block, consider it to be a conducting slab whose thickness is small t. This I have written over here. D is the distance between the plates. Now we have to find the capacitance of the capacitor. Okay, as there is a positive charge over here, there is a negative charge over here, there would be an external electric field that would be going from positive to negative. So let this be the electric field. It will be E naught, that is of free space. Now, what happened when conductor is placed in between? See, there is a similar topic to it, that is of dielectric slab, that we would be covering in our next video, that I would be covering in the next video. Now, if you remember a conductor, if you remember the properties, there is no electric field between or inside the conductor. So there will be no electric field inside the conductor. There will be no electric field inside the conductor. And when dielectric would be placed, dielectric would be having an internal electric field. This is the difference between conductor and a dielectric. That conductor, inside conductor there is no electric field, but inside dielectric there would be electric field. Okay, we will come to that later on. Now let us start with how you will derive an expression for capacitance of this capacitor. Now if you see this E naught is traveling in which direction? This is from positive to negative. But in which part? See, it cannot go inside the conductor. It will not go inside the conductor. It can only go in this part and this part. What is the value of this part? This whole is D, this whole is T. So you are left with D minus T. Now, if you remember the formula of potential, that was E into D. So it becomes E into D minus T. Why D minus T? Because this E naught can only go in this part, that is D minus T part. That's why V is equal to E naught into D minus T. Now, what is the value of E naught? That is electric field between the capacitor. That was sigma by epsilon naught. So the value of V, this potential difference between the plates, is sigma by epsilon naught into D minus T. You have to find the value of capacitance, right? Before we find value of capacitance, let me place the value of sigma. Sigma is given by Q by A. So it becomes Q by A epsilon naught. What is sigma? Sigma is surface density charge. That's value is given by Q by A. Now, why we are doing this? We are doing this to find capacitance. The basic formula of capacitance is Q by V. So put the value of V over here. So what you get? You get Q upon Q by A epsilon naught into D minus T. No problem here. This Q and this Q cancel out each other. This A epsilon naught comes in numerator. So what you get? You get A epsilon naught upon D minus T. Now if you take D common from denominator, what you get? You get 1 minus T divided by D, right? So the value of C is equal to this. This is an expression for capacitance when conducting slab is placed between the plates. Now, if you see this value, this is A epsilon naught by D. This was the value of capacitance when there was nothing in between. That is the basic formula of a parallel plate capacitor. Capacitance of parallel plate capacitor. This can be termed as C naught. So you can also write the value formula, this formula as C is equal to C naught 1 minus T by D. So this is the formula of capacitance when a conducting slab is placed in between.